All right, so for the first part of today, we're going to talk about isotopes. In this lecture, we're going to identify isotopes, we're going to define them, we're going to be able to name them. In the second part of this lecture, lecture part 2, we're going to talk about how to calculate average atomic mass. So what is an isotope? Well, to talk about isotopes, the first thing that we've got to be able to do is we're going to remind ourselves about our history. And we're going to talk about this guy I know and loved, John Dalton. Remember, John Dalton, as part of his atomic theory, said that all atoms of an element are identical. They are the same. As it turns out, he was a little bit correct. He didn't know about atomic number, but we now know that all atoms of an element have the same atomic number. So if you have a sample of hydrogen, all the atoms in that sample all have the same atomic number. If you have a sample of uranium, all the atoms in that sample have the same atomic number. What is not true, however, is something that Dalton said. He said that all of them must have the same mass. That is actually not true. Atoms of an element, right, even though all the atoms in my sample can all be hydrogen, some of them can have different masses from the others. They don't have a range of masses. They don't all have different masses themselves, but they can have different masses. Just because you're hydrogen doesn't mean you have the same mass. And we call atoms of the same element with different mass isotopes. And sometimes they have different properties. Not all the time, but sometimes they have different properties. A great example of this is uranium. When it was first discovered, they had no idea that it had 3 isotopes, but it does. It has uranium-238, which is the main isotope. It's only barely radioactive. And believe it or not, they can take that uranium, which is often called depleted uranium, and they can turn it into bullets. And those bullets are, because uranium is more dense than lead, are actually much more effective than lead bullets. Interesting fact for you there. Uranium-235 is the element that we use in nuclear reactors, and we used to use in making atomic bombs. So it is the nuclear they're both radioactive, but only 235 is useful in nuclear reactors and atomic bombs. Uranium-234 is super unstable. It doesn't exist for a very long time, and it's not really used for much of anything. What's interesting is at the end of the semester, we're going to talk about what radioactive decay is. We can take uranium-234, let it decay, and one of its products there, when it does that, is useful. But it's kind of the rarest of the 3 in the sample uranium. More on that in a minute. Hydrogen, the other example I used, is also different. It actually has 3 isotopes. My picture keeps moving there. It actually has 3 different isotopes. The first isotope is called hydrogen-1. We just call that one hydrogen. The second one, hydrogen-2, was so popular, they gave it a different name. People didn't want to call it hydrogen-2. They called it deuterium. And it has a lot of neat uses. It's actually often used in nuclear reactors to help quench nuclear reactions, which is kind of neat. But the most interesting one is hydrogen-3, which everybody's probably heard of. Its name is actually tritium. And if you watch that old classic movie, such classic, such good, Spider-Man 2. In Spider-Man 2, Doc Ock, pictured here, Doc Ock is trying to find a sample of tritium, and this is actually what we use tritium for today. They found that tritium is very easy to use to make fusion. So tritium, or hydrogen-3, whichever way you want to call it, can be used for fusion. They're trying to build a fusion reactor right now over in Europe. Thank goodness it's over there. If it goes, super critical, it could explode and destroy a chunk of Europe. But oddly enough, create very little to no radiation whenever it does that. If you haven't watched Spider-Man 2, just go out and watch it. The Sam Raimi Spider-Man's the best Spider-Man's, of course. But anyways, those are just a couple examples of elements that have multiple isotopes that all have different properties. How do you name an isotope, right? I just named a few for you. Where does that name come from? Well, if we take, for example, an atom that has 34 protons, 34 electrons, and 38 neutrons, we know from that example that means that Z equals 34, A equals 72, C equals 0. And here's where I'm going to throw in a little bit of tidbit of information. When we're doing this isotope stuff, we're not too worried about charge. And so you're allowed to assume in all these problems that we do today and tomorrow, if I don't tell you what the charge is, assume charge is 0. So we look at this, this isotope right here. To name it, what we're going to have to do first is find the name of the element. So the names of the elements are all on the periodic table of elements. Now later on, we're going to spend a lot of time on this thing, why it's shaped this way, why everything is laid out the way it is. But the most important thing for you to know right now is if we look in the top part of each square, that number in the top is actually the atomic number for all the atoms of that element. If you remember, right, atomic number is number of protons. All the atoms of, in this case, tennessine, have 117 protons in them. So atomic number, the table is arranged from left to right, starting from the top and working our way down. So there's hydrogen. Helium is kind of hidden up by my picture here. But lithium, beryllium, right? Lithium's 3, beryllium's 4, then 5, 6, 7, 8, 9, 10. So it's just like you read a book left to right, top to bottom. We're going to find our element. Our element was atomic number 34. So we're going to go all the way down here to find element number 34. That element is selenium. So we've got an element here that is selenium. And so selenium is the name of the element. So the isotope, to name an isotope, you take the name of the element and you add to the end of it A, which is the atomic mass. So the name of this isotope would be selenium-72. And you'll notice there's a dash in between them. That dash is just there to divide up. And some people leave that off, by the way. I've been Googling this a little bit, and you see some people leave that off. That's not the usual way to do this. The usual way to write this is to write selenium-72. That's the isotope. So here's a practice problem for you. If you need to, you can pause right here. You can try out this practice problem, see if you can figure out the name of this element. You can also do pen for this element. I'm just going to jump straight into the name. You could also pause on this slide, which shows you the list of the names, if you so desired. The atomic number there was 12, so I'm going to go straight to element number 12, which is magnesium. And magnesium is the name, and there's the atomic mass, so the name of this isotope would be magnesium-24. Fairly simple. There's two problems, going from pen to the name of the isotope and going from Zach to the name of the isotope. We can do it either way. We're going to stop this lecture right here because there is another activity that you're supposed to do, a PhET activity that I'd like for you to work on. It's kind of fun, kind of experimental. If you have trouble with that, hit up your group in Teams, or you can also just send a message to me in the main window.